So here we go. AP problem, and then I think I have averages on this. So let's see. All right, so for part A, wouldn't you agree that when you read average, your mind should go one of two ways. Average value or average rate of change kind of thing. And it totally, which way, totally depends on what they give you. In this case, they want average acceleration. So average acceleration as it relates to velocity is rate of change in acceleration, yeah? So you should be looking at change in velocity over time, and your answer is 11/20 feet per second per second. Would you please start to get in the habit of underlining keywords like indicate units of measure so you don't forget? 11/20 feet per second, or feet per second squared. It was 1 point, and if you didn't have the units, I believe you did not get that point. So give yourself 1 or 0 out of 1. Questions so far? Cool. Okay. B, using correct units, explain the meaning of this. Integrating a rate of change gives you an amount of change. That is one of the huge ideas of calculus. So one way to interpret this is to say integrating a rate of change gives you amount of change. Then the question is change in what? Well, what is the antiderivative of velocity? Position. So you might say this is V or H or X, whatever. H at 70 minus H at 10. If you would just say, well, I know this fundamental theorem of calculus says I take the antiderivative and subtract. And if you were to write this, your chances of getting it right are substantially better. Oh, so when I do this, it's H of 70 minus H of 10. That's the change in the position. So the idea here is, now I don't know if I would have got full credit here because it is change in position, that's true. They also say distance because it's all only moving forward or up. So I'm not sure if I would have got full credit. I just said it's change in position in feet from time 10 seconds to time 70 seconds, but I guess the moral of that story is if the velocity is positive, then distance equals displacement. And so maybe I should have said distance here. I think I just lost the point. That's a pity. Okay? If it's always moving the same direction, let's actually review this. We know that this is distance, yeah? And this is displacement. But if velocity is positive, isn't absolute value and velocity the same thing? And so you would get, okay. Yes? If you said, yeah, that's a good question. I can't remember the board notes on this. I think you would get it. The thing is, though, if somebody remembered it wrong and they thought this was always distance, would that get them? I'm not sure. Give yourself the point, but in the future, make sure you distinguish. Okay. Then the idea is midpoint. I hope, again, remember, this is the big times. You want to give your best work. So me, I might not do this on the homework, but on the AP test, I say, okay, so if this is a midpoint sum, I'm doing prereq. I skip no steps unless I'm worried about time. And then I said, all right, if it's midpoint and I'm going from 10 to 70 in 3, then what's my delta x? But by 20s, yeah? So the first rectangle needs to go from 10 to 30, and the midpoint between 10 and 30 is at 20. Then from 30 to 50, the midpoint is 40. And then 50 to 70, the midpoint is 60. So they factored out at 20. I wasn't sure. I don't know. I just started doing something like this. I did 20V at 30, 40. 20, right? Was it 10 to 70? I can't remember. Yeah. Okay. So 20V at 20 plus 20V at 40 plus 20V at 60. And that gets your estimate of 2,020 feet. If in your work you clearly used v at 20, v at 40, v at 60, then you get the idea of a midpoint. You get that point. And then one pointless, you're actually getting the answer, the base times the height. All right? So give yourself 0, 1, 2, or 3 there. Moving on to the last one. This one required technique, integration technique, which is why I put it on this side. The only way I can know which one is traveling faster is to compare their velocity, right? I know from the table, velocity A at 80 seconds is 49 feet per second. The only way I'm going to get velocity of rocket B is to use the acceleration. So next thing is you ask yourself, okay, what's the calculus relationship that gets me velocity from acceleration? Is it derivative or antiderivative? Antiderivative. So hopefully you said, all right, the velocity of B is the antiderivative of 3 over root t plus 1. Now in their work they did not show, you could do this in a fundamental theorem way, a definite integral way, or a find it and plus c kind of way. So either way there's two possible choices. Many people, at least the way I taught this, would use sub because you do kind of have a function within a function. So let's say I did it this way. If I did u is t plus 1, then du is dt, and the integral becomes something like 3 du over root u. That's 3u to the negative 1/2 du. By power rule, I raise the power, divide it by the nu, so I get 6 square root u, which is 6 root t plus 1 plus c. Now I use the initial condition. This question is designed to nail somebody who thinks, oh, the c is always the initial condition. So if you just put 2 here, you lose. You do not actually take the time to put in the initial condition. You should say, hey, at time 0, the velocity is 2, and if you put that in, because there's that plus 1 there, you actually get something like 2 equals 6 plus c. That c is negative 4, not 2. Actually put the initial condition in and find the c. Do not assume that the c is always the initial velocity. It is not always the initial. Okay, so the velocity at B is 6 root t plus 1 minus 4. Therefore, the velocity at 80 seconds is 6 times the square root of 81 minus 4, or 6 times 9 minus 4, which is 50 feet per second. If I compare the two to see which one's going faster from the table, A was going 49, B is going 50 for my work. So I conclude that rocket B is traveling faster at time equal 80 seconds because 50 is greater than 49. All right, so in terms of time, or units, or sorry, points rather, first was, did you get the antiderivative correct? Is the antiderivative 6 root t plus 1? Second is, did you get a constant of integration? Now, if you did this in a fundamental theorem kind of way, if you did something like the position of B, height of B is height initial plus the change, then your points will be a little different. 3 over root t plus 1, x plus 1. That is another possibility, is to do fundamental theorem with an definite. But at any rate, these 2 points are using the initial condition and integrating properly. And then the last is, did you compare correctly to rocket A and conclude that B is traveling faster? Yes? That was 4 points. I guess, sorry, I misled you. When I said the answer to 1 had to have units, it didn't. If you had 11/20ths, you were good for 1, or for part A. there was a units part at the back end. It said to have units in A and B. So if in part A you had feet per second squared, and in part B you had 2,020 feet, then you are good to go. Okay? I didn't say that well. Okay. How'd you do? Did you get an I? I hope. Alrighty then. This class, it feels actually better today because now at least it feels like there's a reason for it to be super quiet. It's a small class. Am I right, ladies? Right. Okay. So here we go. Notes. The notes on antiderivative or integration technique. Applications are harder. Generally, it involves writing like that problem did. Stuff. You need to make hay on the multiple choice and the 3 or smarts or hearts that are just integrate this thing. Okay, those are up in our wheelhouse. We need to make sure that we can kill integration technique. So let's go here just to remind you, when you have an integral, how do you do it? Kind of ideas. You ready? Cool. When you try and undo a derivative, you say, I'm trying to find the antiderivative. What I beg you, please just check your antiderivative answer with a derivative. Answers to derivative and antiderivative questions can often be checked if you just take the time to do so. Sometimes multiple choice problems, you can actually get to the answer correctly and quickly by taking derivatives rather than actually figuring out the antiderivative. The power rule. If you integrate something with a power derivative, you reduce the power by 1 and divide or multiply. In antiderivatives, you increase the power by 1 and divide. Don't forget the plus C, senor. All right, so sometimes, however, you need to be careful to clean the problem up before doing that. For example, if you were to crank out the power rule here and think, oh, the power is 2/3, you would be on a fool's errand because the power here is not 2/3. It's negative 2/3. So make sure that you write it in the correct form before applying the power rule so that you get a correct answer. When you raise it by 1, what's negative 2/3 plus 1? X to the 1/3. Divide by the new, which means divide by 1/3 or multiply by 3. And so we're getting something like 6 times the cube root of x plus c. When you integrate, you raise the power by 1, divide by the new power. Be careful to apply it correctly. For example, here, if you were to say, hey, I could just integrate this and call it 1/3 x squared plus 1 cubed, that is not true because there's something a little more going on there. There's a function within a function, and you'd have to deal with it. How would you deal with this one correctly? How would you integrate that one? You could u sub it. I'm afraid that you would probably be out of luck here because your u would be 2x dx, and there isn't one, so what's another one? Remember to simplify your life algebraically if possible. So what can you do? You can square it. This is x to the 4th plus 2x squared plus 1. Okay? So if it's clean, integrate it. If it's not clean, can you do some algebra first? Then integrate it. 1/5 x to the 5th minus plus 2/3 x to the 3rd plus x plus c. Okay? Some gotcha problems. 1 over x. Is that a power rule problem? It is not. Instead, it's a special case of natural log. Natural log. This is a classic gotcha question. Haven't I multiplied? Marked you absent. Sorry, I don't know why I did that. Bolton is here. Okay, sorry. I guarantee you this is one of the most missed questions on a typical Calc 1 test. Natural log, 1 over x? Heck no, because that's just the derivative, not the antiderivative. 1 over x No, it's actually integration by parts. You have to do ultraviolet voodoo to get that one. It's a classic trap question. Okay? 1 over x squared. Is it 1 over x? No, I'm going to rewrite this, Mr. Rickman. I'm going to take the time to say, all right, if I rewrite that first, then power rule, it's raise it by 1, divide by the new, so it's actually negative 1 over x. Let's see, not 1 over x. Take your time, make it, rewrite it cleanly. This, I don't even know what my point is of this, but how would you integrate this? Function within a function, seems like you could. What about trig identities? Isn't that equal to cosecant? Yeah? What's the antiderivative of cosecant? Do you remember? That's a shame. It's negative natural log of cosecant minus cotangent. I think that's on my memorized derivative list down below. Okay, antiderivatives. All right, so my point though is don't let your little eyes light up and circle the thing that jumps out of you because it might be a distractor. Slow yourself down and think, okay, hang on a second. Can I rewrite this cleanly? Am I missing something? It could be easy, but it could be you're oversimplifying. All right, rules for working with integrals. When you have a sum, is it true that you can integrate each part of the sum separately? True? Yes, true. When you have a product, can you integrate each part separately? Is that allowed? No. You cannot split a product. You can split a sum. You cannot split a product. Lee? This. You would have to, can you move the 3 out? The 3 you can move out. Can you move the 2 out? No. Okay, you can move a coefficient out front of a function, yes, but a number inside a function, no. All right. This also goes to make your life easy, technique kind of questions. If I gave you this integral, how would you do it? Yeah, split it up into x over x plus 1 over x, I heard. If you split, you can split a sum in the numerator. Split numerator sum, that is allowed, and that does make your life easier. What's the antiderivative of 1 with respect to x? X. And what's the antiderivative of 1 over x with respect to x? Natural log of the absolute value. Okay? Does the same rule apply in reverse? Can I split this up into 2 separate fractions? Is this allowed? No. Now let's, rather than give you a fish, let's teach you to fish here. This, say you had this, sum in the numerator. This is how I got stuck in this. I think, that feels right? Is that right? Well, think about it to yourself. Could you split this, and would it still be true? 5 over 5, this is 5 over 5. Is it still true if I split that? Okay, what about this? 5 over 2 plus 3, 5 over 2 plus 5 over 3. Is that true still? This is 1, this is 2.5 plus more than 1. Is that true? 100% not true. You cannot split a sum in the denominator 100%. No, no, no. Numerically, that is not allowed. That's broken math. You just broke math. How would you do that? That's a stinker. That's what you call, or at least what I think of as an unfortunate sum problem. And this is actually one case where you might use something. Let's say let u equal x plus 1, so that this is just a single term in this numerator. Then what is x equal? X minus 1. Now making that substitution, oops, so x equals u minus 1, sorry. Making that substitution then moves the sum from the numerator to the denominator, and dx and du are the same. That then can be split. So it's 1 minus 1 over u minus log of u, and then you sub back, so it's actually x plus 1 and it's log of x plus 1. Let's see. That's a bit of a gotcha problem. Okay. All right. This guy. This is complicated. Can you think of anything to do? It's not a U sub problem. I see two terms, but it's not a U sub problem. So what else could you do? Think algebra. What? You could factor and hope something cancels, which I designed this problem so nothing did. So that's a good idea. That's the first thing you should have looked at, is to factor and cancel. What else? Think geometry. Or not geometry, algebra. Divide. Okay. You can always divide. You want to do synthetic or long division? Synthetic, I heard a little of each. Let's do both, just to review. If you synthetic, what goes in there? 2 or negative 2? Negative 2. 1, 7, 4. 1 comes down, negative 2 there, 5, negative 10 there, and I get negative 6. Great. What the heck did I just get? What does it mean? What's my answer? This is my answer. X squared, not x squared. You divided x squared by x, so that is x plus 5 minus, and the remainder is 6 over x plus 2. Now that's a giant leap forward because that can be integrated. What's the antiderivative? 1/2 x squared plus 5x minus 6 log of absolute value of x plus 2. You could use sub that, but because it's addition, I don't know if you would need to. You with me? That's a trap. This one is a classic. This is a good final exam on a calculus in college question because it evaluates several skills. Do you have any idea? Okay, so on one level it feels like arctangent because it's x squared plus 1. On another level it feels like u sub because x squared plus 1's du would be 2x dx, yeah? And you're actually both right, but only after you split it. You would split this first, so it's x over x squared plus 1, and that's u sub. And then 7 over x squared plus 1, and that's arctangent. If here you let u equal x squared plus 1, du is 2x dx, so du over 2 equals x dx, right? U sub is coming later, but we'll do a little here and there. So when I go to substitute, I would get du over 2 over u, yeah? Are you with me? The antiderivative of which is 1/2 log of absolute value of u plus c. So 1/2 log of absolute value of x squared plus 1 plus c. I don't need to write the plus c because I still have to integrate a second one, so I'll just put 1 plus c after. I'm all done. Are you with me? Multiple choice wise, is the absolute value necessary? If you didn't see absolute value, is it wrong? X squared plus 1, is it always positive? It is. And so if they left out the absolute value, it actually would be exactly the same. So this could be 1/2 log of parentheses x squared plus 1. It wouldn't be wrong because it's positive. It could also be log of square root of x squared plus 1 by log rules. Okay, so multiple choice wise, sometimes you need to be able to figure out which one's equivalent to your answer, right? This guy, that 7 is screwing up my arctangent. What can I do with it? Now you can move it out front. 7 times the integral of 1 over x squared plus 1, which makes the last part of the answer 7 arctangent of x. Okay, that one had a couple different components to it. Okay, you need to have these down cold memorized. The antiderivative of cosine. Sine or negative sine. Remember, you're talking antiderivatives. Get your answer and check this makes sense. What's the derivative of sine? Cosine. Yes, that makes sense. Sine, cosine. Check does my answer make sense. Is the derivative of cosine sine? No, it's negative sign, so this must be negative cosine. Tangent, if you had to show the work, it's an identity of sine over cosine with u sub, but more commonly, you need to have it memorized, and it's most commonly known as natural log of the absolute value of secant. Okay? Antiderivative of e is e, but be careful. Don't think anytime you see an e, it's always the same. If they throw something like that at you, then you need to slow yourself down and say, I'm going to rewrite it. Oh, there's a negative. I get the u sub. Slow yourself down. Okay? So don't see e and think, ooh, boom, same. Sometimes there's more to it than that. Natural log is x, natural log of x minus x plus c. It's by ultraviolet voodoo. I don't know if you really need to have that memorized, but I want you to be prepared in all cases. So, sometimes an antiderivative is testing whether you know your derivatives. This, for example, is a derivative of tangent. So it's really testing your derivative skills as much as your antiderivative skills. What's the antiderivative of secant tangent? That's a known derivative. What's that derivative of? That's the derivative of secant. 1 over 1 plus x squared is our tangent. It's got to be plus, got to be squared. 1 over square root of 1 minus is arc sine. Those are the big two that you really need to have memorized. All the others, you'll typically do the others in Calc 2 with trig sub, it's called. So I don't know if I commit to memory any but those. And then anytime you integrate absolute value, think piecewise. Just like in derivatives, absolute value screams piecewise. What is it like on the positive side? What is it like on the negative side? Okay? All right. U substitution. U substitution is not some little skill. It's a huge skill. And I've looked at about 5 different tests, and U sub is usually about 5 multiple choice questions out of 45. That's no small thing, and it's also on the free response. It's a big skill that you need to be able to do. If they say use a change of variable to do this, blah, 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 change of variable is the same as use sub. Some textbooks call it use a change of variable. That's the same as use sub. So, for example, in this case, can I do algebra? Can I distribute that x in? Or no, algebra doesn't allow me. Can you distribute the x? Let me give you a comparison problem. Okay, these two, although they look almost identical, they are different. This I would distribute because I can. X to the 3/2 plus x to the 1/2, and then I power rule. This, however, I can't distribute that x into the square root. That is a totally different exponent. So that you cannot distribute. That's why you might use sub this. You'd say let u equal, what would you let u equal? X plus 1. So this becomes then the square root of u. That's cool. X is u minus 1. Now we switched it around a little so that we can distribute. By making that substitution, that's what allows us to make this distributing. Boom, now we can distribute u to the 3/2 minus u to the 1/2. So if you get stuck, think, can I do algebra? Can I use sub to make my life better? Okay? This, function within a function. So what would you let u equal? 2 plus 3x, okay? Now I'm going to go slower. Remember the basics of your u sub. After you decide your u, then you go about making your du. You take the derivative of both sides. Du is 3 dx. I don't have a 3 dx, I have a dx. So if I move that 3, then dx can be replaced by 1/3 du. When you go to substitute, then everything should be accounted for. Dx can be substituted with 1/3 du. this whole thing becomes u. If your u sub and the problem's not better, then you u sub better. 1/3 natural log of the absolute value of u plus c. And then don't forget to sub back. Oops, that's 3x. Boom. Okay. This guy, what would you let u equal? Pi over 2x, so what's du? Pi over 2 dx, so what's dx? 2 over pi du, yeah? So you get something like cosine of u times 2 over pi du. You bring out the 2 over pi, you integrate cosine, saying is it sine or negative sine? Well, which one gets me the right answer? It's sine, and then sub back. Now all of those indefinite integrals you sub back. Indefinite integrals sub back. If it's a definite integral, then you change the limits and you do not sub back. So, for example, if I see this and it's a mess and one looks like the derivative of the other, I think u sub, but because it's got limits, I know I have to change my limits of integration. So what's your u? Mac, what's your u, buddy boy? 5 cosine 2x. I couldn't agree more. 5 cosine of 2x. Du then is, be careful with your derivative, is it 10 cosine of 2x or negative sine of 2x or 10 sine of 2x? What's the derivative? Anybody? 10 or negative 10? Negative 10 sine of 2x because dx, because we pick up a negative from the derivative and a 2 from the chain, right? I don't have negative 10 sine of 2x. I have this 3 and negative 10 stuff. So how do I work out those coefficients? Well, the 3 I can take out front, and the negative 10 I can move over. A lot of people just say, I'm going to scratch that negative 10 and move it over. So isn't this the same as 3 over negative 10 of u root u du? Wait. Now in a definite integral problem, you also change the limits of integration. So if x is pi over 4, then u is 5 cosine 2 pi over 4, which is pi over 2. What's cosine of pi over 2? Cosine of pi over 2 is 0. Okay? When x is 7 pi over 4, u is 5 cosine of 2 times 7 pi over 4. That's 7 pi over 2. That's pooping me out. 1, 2, 3, 4, 5, 6, 7 pi over 2 is the same as 3 pi over 2. What's the cosine of that? 0. Shoot, that's nice. What's any integral when the limits of integration are the same? 0. Okay. It must have been the case that you had some cosine action and that there was a positive and negative variance knocking each other out. Okay? Integration by parts. You use u sub when you see a product and one is the derivative of the other. If I, however, see a case where I see a product and one is not the derivative of the other, if they're really just kind of unrelated, then I think integration by parts. The formula of ultraviolet voodoo is given some kind of product, uv minus the integral of v du, ultraviolet voodoo. Don't forget it's negative. Okay? Now, you would definitely want to take care to decide what do you make u and what do you make v. So in this case, for example, I might start by rewriting this and say this is x e to the negative x. Now, is this u sub or integration by parts? Is one the derivative of the other? No. If this were x squared, could you use u sub? Yeah. If u is x squared, then dx is 2x dx, and I'm good to go. But This one is not the derivative of the other, so I think, okay, maybe it's this integration by parts stuff. So I need to decide what is u and what is dv. To choose u, think your best u is log, then log, log, then inverse trig, then algebra terms like x or x squared, then trig, and exponential is the worst. Okay, bye.
Good morning, Dublin Jaguars. Please rise for the pledge of allegiance.
Sometimes good.
Speech begins. I
I
pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Emma's here today. She's never.
Students, boys and girls mentoring, your year-end celebrations will be this Friday, May 3rd. Again, this Friday, May 3rd, for both boys and girls mentoring. Please check in with your teachers and join for the girls. Will be in the cafeteria for pizza and fun. Save the date. The junior high play, Beware the Jabberwock.
So what would you let u equal here? X or e to the negative x?
Tickets are $8 at the door.
X.
Junior high
E is
students,
e to the
anyone who
negative x.
has not done their AP pre-doubling needs to see Miss Harrington as soon as possible to get it done.
You might have to do a little u sub. You could do guess and check for the v. What's the inside derivative of e to the negative x?
There'll be an information
E or
meeting
negative
May
e?
1st during 7th hour in Mr. Boswell's room, E204. Seniors, the countdown is on. 6 days until National College Decision Day. Actually, make that 2 days, May 1st. This date represents the deadline for students to submit their acceptance and make a deposit to attend college. Commit to your school of choice and reach higher to your next destination. With that in mind, please fill out the senior destination form in counseling. The senior montages are hung in counseling. All students are welcome to view a photo collage of the amazing class of 2019. Check out their stellar academic, sports, and music life that they've led. Junior high students, tomorrow 7th graders whose last name begins N to R will be required in the auditorium during 7th hour for ICAP with Mr. Northway. On Thursday, last name
I'll finish the notes tomorrow.
Please plan your 7th hours accordingly.
This is due tomorrow, yes.
Dublin Jags, congrats to the
Blues
girls
due
tennis
tomorrow.
for winning the league and placing first. The Colorado Academy
Yellows
tournament this
due
past
Friday.
weekend. Our incredible girls soccer tied
Oh.
Evergreen 1-1 in double overtime Thursday night at Lake
Yes, sorry.
Field in a game that ended at
Yeah,
9:30
they're both due
p.m.
tomorrow.
Peyton Pritchie scored the Jags on an assist by Lauren Cook. Kira Hess
If
was
you
the
have-
amazing goal
Hey,
with
there you go.
save. Next up,
If you have them done today, you want to turn them in if you like.
keep it going, girls.
Tomorrow, they're both due.
Good morning, staff and students. Students